Are you still with me? Okay, turn to page 4. Let's do some examples. So of course the first thing I did was graph, and in red we have the y equals x squared, and in blue I have y equals x, and then of course I labeled my spin axis, which is the x-axis. And since I have a horizontal spin axis, I want to integrate with respect to x, which means I need my equations in y equals, and they currently are. Now, the reason that I know that there's going to be a hole is because the purple shaded region does not touch the x-axis everywhere. So there's a gap between the purple and the x-axis, my spin axis. So that's how I know I'm going to want to use washers, and I'm going to want to subtract the hole that's created. So I'm going to start with capital R, and just like I've been doing before, I want to find the area under the blue curve, so I'm connecting blue to spin axis. That's what my green radius is doing. And so I want that upper bound, which is x, minus that lower section that it touches, which is the x-axis. So my larger radius is x. And then for my small radius, I want the top part that it touches, but it touches the red curve. So that one is x squared minus, and again it touches the x-axis as the spin curve, which is 0. So my little radius is x squared. So now I'm ready to write my volume formula. So notice I've substituted in x for the large radius, and I've substituted in x squared for the small radius. Now, since I'm integrating with respect to x, I need to see the leftmost boundary for x, which appears to be 0, and the rightmost boundary for x, which of course would be 1, because that's where my two graphs intersect. So I'll be going from 0 to 1 for my boundaries. Of course, when I simplify, I'll get x squared minus x to the 4th. My first step of integration will give me x cubed over 3 minus x to the 5th over 5, and then I'm substituting in 1 first and then 0, which gives me 1/3 minus 1/5, which simplifies to 2 pi over 15. Moving on to problem 2. I'm revolving the same region from example 1, so again I graphed it. The red is still y equals x squared, the blue is still y equals x, only this time I'm rotating it about the line y equals 2. And since my spin axis is horizontal, I'm still integrating with respect to x, and I would still like my equations to be in y equals. So as you can see, I have drawn in the radii perpendicular to my horizontal spin axis, and I'm going to start with capital R. Now, we already know that we would like to take the top function, which is 2, minus the bottom function, and it touches the red, which is x squared. Then for the small radii, lowercase r, again, I want to take the top function that it touches, which is the horizontal spin axis 2, minus the blue function, because that's the other function it touches, which is x. Now I'm ready to integrate. So I'm substituting in the large radius and squaring it, minus the smaller radius and squaring it, and then I'll FOIL. And of course I forgot, since I'm integrating with respect to x, I need to see the leftmost bound of the shaded region in terms of x, and that would be 0, and the rightmost bound of the shaded region in terms of x would be where they intersect, which is 1. So my bounds are from 0 to 1. So I've FOILed, and now I have to distribute and simplify. And when I do, I get this equation after I distribute and integrate, and then when I integrate, I get this, and plugging in 1 and then 0, I get this, which simplifies to 8 pi over 15.